to True Projects. In this video, we are going to explain about the project, which is virtual machine placement for minimizing image retrieval cost and communication cost in data center, that is in cloud data center. So before getting into the execution, first let's understand what is the project about. For example, infrastructure as service, that is IaaS, allows users to access virtualized computing resources such as CPU, memory, and storage through virtual machines, which are VMs. We call them as VMs. So they are launched using large virtual machine images. So these VMs, they are launched using this virtual machine images. As the applications grow and require more resources, their components often spread across multiple VMs. This distribution can create challenges in retrieving these VMs. So, because of this, retrieving these VMs is very challenging, as accessing larger images can lead to increased network congestion and latency, particularly in factory network architectures commonly used in cloud data centers. Consequently, these factors can negatively impact the performance of the applications and efficiency of resource utilization within the cloud infrastructure. So, in cloud environments, deploying numerous virtual machines can lead to inefficient bottlenecks, that means challenges in accessing larger virtual machines images. So, in cloud environments, deploying these virtual machines can lead to significant challenges in accessing virtual machine images. So this elevates communication cost. When VMs are spread across various physical machines, so when they are spread across various physical machines which are called as PMs, the retrieval of these sizable VMI, that is virtual machine images, files can result in increased network overhead and also delays. Furthermore, communication between VMs that are located far apart often requires multiple network hops, consuming valuable bandwidth. So this project seeks to enhance the placement of so this project seeks to enhance the placement of VMs to minimize both the time taken to retrieve VMIs and the cost associated with the inter-VM communication, ultimately improving the overall system efficiency. So this project proposes the placement of virtual machines. So this proposed system improves the placement of virtual machines in cloud data centers through the implementation of three key algorithms, that are PM clustering, VM partitioning, and VM PM mapping. VM is nothing but virtual machine, and PM is nothing but physical machines. So, by organizing physical machines according to their geographical proximity and the resource availability, these algorithms, they facilitate more efficient resource allocation. This strategic clustering not only streamlines the process of retrieving VM images but also lowers the cost associated with communication between VMs, thereby enhancing the overall performance and efficiency of cloud operations. So let's understand what is this PM clustering in detail. So PM clustering involves organizing physical machines into groups based on their geographical proximity and also available resources. By placing physical machines that are closer together and have similar capacity in the same cluster, the system can simplify the process of placing virtual machines onto a physical infrastructure. This clustering strategy not only improves the utilization of resources but also helps to reduce network congestion, as VMs that need to communicate frequently, they are located on the nearby PMs, leading to a more efficient network environment. So, coming to this VM partitioning, so VM partitioning focuses on grouping virtual machines that share similar communication patterns and resource requirements. By categorizing these related VMs together, the system can optimize their placement within PM clusters. This method minimizes the need for communication between different clusters, which can often be costly in terms of latency and bandwidth. As a result, the performance of the application hosted on these VMs improves because related VMs can exchange data quickly and efficiently without the delays associated with inter-cluster communication. And moving to this VM mapping. VM mapping is the process of assigning specific virtual machines to individual physical machines within the established PM clusters based on their communication needs and similarities of their VM images. This mapping ensures that VMs that frequently communicate are placed in closer proximity to each other, which reduces the time and resources required for data retrieval. By minimizing network latency and enhancing the efficiency of data exchanges, this mapping technique ultimately boosts the overall performance of the cloud applications, making the system more responsive and effective. Moving on, as the extension in this project, we are incorporating K-means clustering. It is employed to enhance the placement of virtual machines by evaluating multiple factors like distance, retrieval cost, and communication expenses. This method enables better grouping of the physical machines, which leads to more effective resource allocation and prevents any individual PM from becoming overloaded. Additionally, we optimize this PMs. We optimize VMs. So, what is this optimizing VM? VM, the system can significantly lower retrieval and communication costs, resulting in a more cost efficient and high performing cloud infrastructure. So, in this project, as an extension, we are incorporating K-means clustering and also the optimized virtual machines. So, this is all about the theoretical concept. Now, let's move on to the requirements. So to implement this project, we need few requirements, which are backend languages. So backend languages which are used are Python, JavaScript. Coming to framework, it is used Django. Front-end languages are HTML, CSS, JavaScript, and Bootstrap 4. And database is MySQL. And hardware requirements are processor of 5 and above, RAM of 8 GB and above, and ROM of 20 GB and above. Now let's execute the project. To execute, we need to open the code folder which contains source code files. So let's open the code folder. So these are the source code files in the code folder of a project. Let's understand each of them. How will they be used in the project? So coming to this VM placement folder, in this folder we have some Python code files that will be intended to be dynamically loaded into the project code during runtime. And in this app folder, it comprises of two subfolders. One is static and the other one is templates. And also we have some Python code files. So coming to static folder, in that we have CSS, JavaScript, and Bootstrap files. These files, they contribute to the visual and interactive aspects of the application. And moving on to the templates folder, within this folder, we will find all the HTML pages used throughout the project. It includes pages like index.html, home.html, and more, representing various sections of the website. And coming to the Python code files that will be executed during the runtime of the application, which supports the project's functionality. And this is manage.py file. It is a command line utility that comes with the Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations, and more. And this is run.bat file. Instead of executing the project through command line interface, we have created this Windows bat file to execute the project. Now let's double click on it to execute the project. So double click on run server.bat file. So here manage.py file is compiled. And now Django Framework will host the application at the local host and the port. Now copy this local link provided by the Django Framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here at the end, type index.html and click on enter. So this is the web page of the project, which is displayed in the browser. And this is built using Django Framework. So here in the homepage, we can see two different links. One is user login and the other one is new user sign up here link. So before logging in as user, we need to sign up first. So click on new user sign up here link and add all the necessary details. So the username would be Kishore. Here we have to give his password, give his contact number, give his mail ID, give his address, and now click on submit. So sign up process is completed successfully. He can log in to perform the cloud simulation. Let's log in as the user Kishore. Click on user login and here provide the username and the password. Give his password. Now click on login. So user Kishore has logged in successfully and this is his dashboard. So now we have to click on this define VM and PM to simulate the virtual machines and also the physical machine. So click on that. So here we have to give the number of physical machines and virtual machines. So let's give 4 as physical machines which will be simulated and 16 virtual machines. Now let's click on submit. Here the configuration of the physical machines and the virtual machines has been done. So this is the physical machine's ID and this is the distance of each physical machine and this is the retrieval cost and this is the communication cost of each physical machine. Now let's click on propose VM placement link. So click on that. So here, all the 16 virtual machines are placed to the nearby physical machines. So the virtual machine number 15 is mapped to the physical machine 0. 0 is nothing but first physical machine. 2 means second physical machine. 1 means second physical machine. 2 means third physical machine, according to that. So here, fifth virtual machine is mapped to physical machine 0, that is the first physical machine. Similarly, all the other virtual machines are mapped to the all other physical machines. Now let's click on extension placement link. So click on that. So here also, this was the proposed virtual machine placement, and this is the extension virtual machine placement. So here also, all the virtual machines are placed to the nearby physical machines. But it will take less time to retrieve the cost. So now let's click on retrieval cost link. So here on x-axis, we have number of experiments, and on y-axis, we have the retrieval cost, where blue color represents existing retrieval cost, orange color represents the proposed, and green color represents the extension retrieval cost. So among all the methods that we have used, we can observe that the extension retrieval cost is taking the less time than the proposed and the blue color one, which is the existing retrieval cost time. So now let's try using some more virtual machines and physical machines. So let's define some more. So here let's define 5 simulation of physical machines. That means we are going to simulate 5 physical machines. Let's simulate 10 virtual machines. So click on submit. Here we got all the 5 physical machines: ID, distance, retrieval cost, and the communication cost. Now let's place virtual machines to the physical machine. So click on that. So here all the 10 virtual machines are placed to the physical machines. Let's click on extension placement. So here also they have placed. They will be placed in similar way, but only the thing which will have difference is retrieval cost. Extension technique will take the less time than the proposed virtual machine. So now let's click on retrieval cost. So here is the graph. Now let's see the communication cost. So click on that. So in this communication cost comparison graph also, on x-axis we have number of experiments, and on y-axis we have communication cost. And in this graph also we can observe that the extension technique is taking less communication cost to retrieve the images. That means to retrieve the virtual machines. So now let's click on log out. So this is all about the project. In this way, virtual machines, they can be mapped to the nearest physical machines by taking the less retrieval cost and the less communication cost.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.